Hi everyone, this is Rookie's channel. Yes, today we will work on Proteus 7.7. Guys, Proteus is a virtual simulation software. But before this, let's understand a simple concept that whenever we want to design a system, we need to follow three steps. First, we must have an idea or concept of what we want to design. Second, we need to draw a schematic of that design. Third, we need simulation. If we want to simulate and directly build any hardware, then there are chances that that's not gonna work. So friends, we can simulate in two ways, real and virtually. Real simulation can be done with breadboard and PCB designing. We will discuss these two in PCB designing course. While virtual simulation is done with Proteus and other softwares. Let's see. Proteus has three parts: ISIS, ARIS and Gerbit. ISIS is Intelligent Schematic Input System, which is used for circuit simulation, and we will use it today. ARIS is Advanced Routing and Editing Software. ARIS and Gerbit will be discussed in PCB designing course. Friends, you can see IC of PIC16F887 microcontroller. On left hand side there is a 40-pin diagram which is picked from datasheet. If you would open this IC in Proteus, it will look like this. You can see on right hand side. And you will notice that some pins are situated somewhere else. But you don't have to worry about it because this is not gonna affect your simulation. Now here is the circuit which I drawn with PIC16F887 IC. You can see at pin number 1, I have drawn a circuit of power on reset. At pin number 13 and 14, I have connected a 4 MHz crystal oscillator with 22 picofarad capacitor. This circuit is for synchronization of all internal operations. See, pin number 11 and 32 are connected internally. Also, pin number 12 and 31 are connected internally. It means you don't have to do connections in Proteus for this. Let's make this circuit. Now friends, you have to open Proteus 7.7 Professional. Now open bin. Now you have to select isis.exe option, double click on it and you would see how Proteus opens. Once it opens, you would see a window where we will make schematic diagram. On the top we have certain options: zoom in, zoom out, scaling, save, open, new file. But on the left we have selection mode, component mode and terminals mode. We have other options too, but we will use component mode and terminals mode very frequently. Guys, you know very well that we have libraries where we have books. But you know what? Similar to that, in this software we also have libraries where we get components for our hardware. For that we have to select P, pick from libraries option, write keyword for the component which is needed in schematic diagram or for hardware. Like I have written RES for resistor. Once the option get displayed, you have to double click on it and it gets selected in devices list. Now write CAP for capacitor, crystal for crystal oscillator, PIC16F887 for microcontroller. Now we also needed a switch. For that you have to always write button keyword. Now you can see here we have more than one option available. You don't have to be confused in these kind of situation. You always have to choose active option for virtual simulation. Now you can see here we have selected all the components which is required for hardware or simulation circuit. Now select any component, come to the window and click once. When you would click once, you can see a blueprint available and you can decide at this moment where you want to place it. Okay, once you are done with the deciding, click again and it gets placed this way. Now select another component, and guys, you know what, you can rotate any component clockwise, anti-clockwise with the plus minus keys available on your keyboard. I'm gonna click here. Now select another component, rotate and place. I have already selected capacitor, so I'm not gonna select it again for placing, right? Now another important step is wiring. For that, come to the end of the component, click once, and come to the end of another component and click again. This way wire connects two components, and I'm gonna connect this way other components too, like this. Guys, always try to make neat and clean schematic diagram. Don't do like this. Okay, zigzag wires don't look good. Always try to make a neat and clean schematic diagram. Now, another important step is to set the values for the components. Like you can see here, this capacitor is having value 1 nanofarad, but I needed a capacitor with 22 picofarad value. So what I'm gonna do, I would right click on it and select edit properties, and now here I'm gonna write 22 picofarad value and click OK. This way I'm gonna set values of all components according to my need. Like I needed a crystal oscillator with 4 megahertz value. Now friends, we will finish the upper portion of schematic. Place a resistor, capacitor and a switch. Do wiring this way. Guys, remember that this dot shows basically the junction of wires. Okay. Now, like this capacitor should be of 0.1 microfarad, so we will change value here also. Now another important step is terminals mode. Yes, we have to add power and ground to the circuit. Now do the wiring and complete the circuit. Now guys, you will notice on the top left corner we have two boxes, green and blue. The blue box basically sets the boundary for the schematic diagram, and you can change it by going in system and choosing set sheet sizes option. Now the green box basically set the view for schematic diagram. Like by clicking on it, you can set it according to your convenience. Guys, you can easily drag and drop the components or wires for making a neat circuit, and there is no extension for saving ISIS files. As practice makes everyone perfect, so I am giving you some circuits which you can practice. Here is a schematic diagram with LM358. You can take a screenshot or pause this video to draw it. Here is another circuit for power supply. Remember that keyword for 2-pin connector is CONN-SIL2. Guys, if you learn 8-bit programming first, then you can easily understand programming for other bits too. So in next video, we will learn programming for 8-bit. If you find this video useful, don't forget to like it, and for further learning, subscribe my channel. Thanks for watching.